Hi, in this video, let us discuss how to evaluate limits only in an informal and intuitive way using a table of values. So we'll be guessing the limit of a function using a table of values. So here's the limit I would like you to consider. Limit of sine of theta over theta as theta goes to 0. And we will show only in this informal way that the limit is actually 1. So construct a table of values in this manner. Remember the input theta is in radians, and so choose some values of theta. We would like theta to approach 0. So as you remember, theta approaching 0 means we need to consider theta approaching 0 from the right hand side and also theta approaching 0 from the left hand side. That is why out here, if you think of this number line, 0 out here approaching from the right hand side is from these positive values, and approaching from the left hand side on the number line is from these negative values. I've put in some values. You may choose a different set of values and complete this table. If you're using a calculator, make sure it's set to radians. You can also use any other technology tool you like, and from there I hope it's easy for you to see that the limit is in fact 1. So some things for you to remember. As I said before, theta is in radians, and also you might consider sketching this function and noting that the limit answer that you get is very consistent with the graph that you see. And remember, this is only an intuitive way of figuring out limits. At a later point, we can use some algebraic and rigorous methods to once again prove that this limit is exactly equal to 1. This is an important limit that shows up in calculus, so make yourself familiar with it. So anytime you see limit sine of theta over theta as theta goes to 0, I want you to be able to remember that the limit is 1. Hopefully this way of exploring the limit is sufficient for now to informally convince you that the limit is in fact 1. Now let's look at a few more limits. Here I have limit of square root of x as x approaches 0. It does not exist. Construct your table of values, and this limit does not exist. This is so because you will see that the limit of square root of x as x approaches 0 from the right hand side is 0. Once you complete your table of values, you should be able to see that very easily. And limit of square root of x as x approaches 0 from the left hand side, it does not exist. You'll quickly see that square root function is not defined when the input values are negative numbers. Now let's look at this example. Limit of 5 to the h minus 1 over h as x approaches 0. Convince yourself that this limit is in fact ln 5. As before, complete your table of values. Here you would put in values so that it's clear that h approaches 0 from the right hand side and left hand side. So pick your values. Some of them negative numbers very close to 0, some of them positive numbers very close to 0, and convince yourself that from this table that this limit is in fact ln 5. And here's one more for you to explore. Limit of this is called actually a rational function, x plus 7 over x plus 6 as x approaches negative 6. Notice that the function is not defined for negative 6. And once again, create your table of values. I've given you some values for x. You may choose a different set of values. You'll very quickly conclude as you approach negative 6 from the right side or from the left side, these values, they do not settle down on a finite number, which is why both the right hand limit and the left hand limit, they do not exist, and hence the two-sided limit does not exist either. For each of these examples, feel free also to draw a graph after you complete the table of values and see that the conclusions you arrive at are consistent with what you see on the graphs too. So this is one way you can guess the limit of a given function by creating a table of values. And this is simply an informal and intuitive approach to limits. Thank you.